CATIA V5 projecting sketches. So within part design, I have this part and I want to project a sketch on this surface over here. Therefore, I created a plane, as we can see from the reference plane, 150 millimeters. I will select that plane. I will also fit to better see where I'm sketching, and I will create an elongated hole over here. I will also add 5 millimeters for that. And now we see we have that sketch position over here. In order to have this projected onto the surface, we are going to need to use a feature that is not available directly within part design, as we don't have an icon directly for that, but we can use the bottom part and we can input the feature over here. So I will type in C:, and after that projection. I will press enter and I will see that this will do the projection definition. So over here we have to define the projected, in this case will be the sketch, and for the support we need to select the surface. In this case, as we can see, we have this closed surface within part body 2 over here. Afterwards I will click on preview and we're gonna see how that sketch will be projected onto the surface. The only problem is that with projected sketches you cannot work directly within part design. Therefore, if I will select project 2 over here, I will try to do a pocket. You're gonna see that this selection is not recognized by part design. So as you can see, we cannot select the projection over here. I can select the original sketch over here, but the main problem is that this cut will not be, let's say, tangent to that surface. So in this case, if I will further extend the depth, maybe to 70 millimeters, we're gonna have the part cut like this. So if I will hit preview, you're gonna see that that profile will go based on that direction directly to the part. So it's not exactly what we want. Now, in order to work with projected elements, we need to swap to a different workbench. We can go either to wireframe and surface design, or we can go directly within generative shape design. And over here, we're gonna need to define an surface, an extruded surface using that projected sketch. So with that selected, I will go for extrude. And as we can see for the extrude, if I will type in for limit to 20, this will go over here, but we also need to define the direction that we want to use in this case. So for the direction, we can go with either the default ones, or we can create a line in this case, which will be a little bit better. As you can see, if I will add X, for this won't be a viable solution. But if I will go with the Y-axis, again, this is not tangent directly to the surface, but in this case we can have that cut defined. So I will just add a limit with reverse, so I want the cut to be within the part. We don't see that visually over here since we have our solid part body covering everything, but keep in mind that if I will extrude this 20 millimeters on the inside, if I will swap the visible space over here, I will see that I have the part over here as a surface, but now I have the possibility to use split. And in this case, I want to split this element, which is closed surface 1 over here. And for the cutting element, I will select the extrude. And now if I will go with the other side, I can have that cut. So it's the same workflow that I previously used over here. But we're going to start also at the end from scratch, so that if you want to follow along, you can easily do that. So I had that hidden. Now I have over here the closed surface, and I also have the split over here. If I will hide the closed surface, which is a solid face, we're gonna see that this will be our trimmed part. And now we have the possibility, if you want to define a closed surface over here, we are gonna need to do some filling. So using the fill tool, I will select this. We need to select everything until we have a closed contour over there. Again, if you want to define a solid body, we can add thickness to this if you want to. So it's not mandatory that we add that solid body. For example, if I will go to part design, over here at the top where we also have the closed surface and by default split, I can add a thick surface. And over here I can select those, but now if I will only select this, as we can see, this will be split 1. And this will only add thickness to that part over here, which is currently also hidden, as we can see over here. So if I will hide this and hide this as well, let me hide that. This is why I also have over here part body, afterwards body 2, because it's way easier to work directly with different bodies. So let me just quickly insert a new body over here, which will be body 3. And over here I will copy the split and also the fill. So the split will be this one. We're also going to have the extrude. So I will select those 3. I can either copy them individually, or I can do a join and have those all moved over there. It will be the faster approach in this case. So I want to join the split, the extrude, and that filling over there. And now they are all over here, as you can see underneath body 3. And I have the possibility to hide the other bodies, and this will be the only surface that are currently over here. And now I can go to part design, or I can do a thickness directly over here at geometry shape design. The difference will be that over here the elements will have this purplish color, while in part design it will have the custom part design color. So other than that, it will be the same geometry with the same thickness that we can specify over here. As we can see, we can define that. And afterwards, if I will hide the yellow surface, we are just going to have that area. Now, if I want this to be a closed part, which will be, let's say, easier to work with within part design and most common, I have the possibility to go and fill those as well. They will each have to be filled individually, so you cannot add multiple closed section over there. I will do the same for the top and down circle over here. And now with the final join, I can have all those joined together. And this will be join 3 over here, that if I will hide that, everything underneath body 3 will hide. And now I can either use the closed surface over here, or I can go and make use of the one from part design. Again, they will have the same functionality, just a different color, depending on the workbench that was created. And as we can see, we have that projected sketch that we previously defined, which was over here, as we can see, projected 2. If for some reason I want to roll back over here, since this is a different body, I can do that. I will just hide, in this case, show the body 2. And I can go on the projected element and I can define this as a work. Or I can go for the sketch and define the work over here. Therefore, I can start and reshape this. And if I will try to maybe make this larger, for example 8, we're going to see how the part will turn red. And as soon as I will leave that, also our body tree, which was copied over here from this split that was afterwards filled and joined into a surface, will automatically update over there. Okay, so that's how you can project sketches within CATIA. Now I will also create the part from start, and we're gonna discuss over here how we do those cuts for circles and what are those difference between a direct cut or a projected cut. So within mechanical design, part design, I will create a new part. I will select the Y and Z plane, and over here I will define a circle, diameter 200 millimeters, and I want to have this padded on a distance of 40 millimeters in total. Now, since this was created directly within the Y and Z plane, if I want to do a cut which will be perpendicular on the Z-axis, I can easily do that by going over here. I can elevate, I can offset a plane. In this case, I know that a plane at 100 will be, let's say, tangent over here. As we can see, we have that plane. I can enter a sketch over here and I can easily define a circle, for example, diameter of 20. And if I will cut 20 millimeters with this, we're gonna have this cut. But as you can see, even though the plane was tangent, our original sketch is the one on top, and afterwards the cut is over here. So we're gonna have a little bit of clearance over there, where we have that material trimmed for 20 millimeters. That means that on the bottom it will be like this, as you can see. So we have that sketch all the way 20 millimeters. Now another approach would be, if I will, for example, move this plane even more, 150, it will be positioned over here. Again, we can use the projection in order to have this projected onto the surface. For this, I will go directly within generative shape design, since this is faster, and I will use the projection of that on this support. And as you can see, we're gonna have that projected over there. But in this case, this projection is quite distorted, as you can see. This will be the nearest solution, and we have the projection type normal, or we can do it along an axis, along Z-axis. You're gonna see that along Z-axis that will not be let's say disproportional, and we'll have the same circle aspect over here. But again, within the part body, we're gonna have the same problem, since this is a projection. We cannot use this directly within part design, because just like we saw previously, this sketch won't be visible within the pocket. And we should do the same approach with an extrusion over here, surface-based extrusion, where we're gonna keep this. And in this case, it's quite easy, since we have the direction over here, which will be along Z-axis. We can do that reverse. And now we can just do that splitting. So within split element to cut, we know that will be the padded element, and cutting element will be the extrusion. Now we can swap with other side what exactly we want to keep after the split. But in this case, we want to keep the large part with that cutout. And we're going to see that after I will click OK on that split, we're going to be within this situation where we have that cut, but we have the pad position on top over here. This is why, for example, if I will try to hide this pad, we're going to have that surface over here. But it is better to work with different part bodies when you are working with splitted elements. Therefore, within the part, I will define a new body, and I want this split to have this copy and pasted over here. We can paste this directly as a result. And now if I will hide part body 1, we are just gonna have this. We also need to copy the extrusion, so we could also join those just like we did previously, or we can do this approach. And at the end we have to fill this and also have all those join within a single surface, because otherwise CATIA won't be able to define the solid body for this. So now for join 1, I can go within part design, I can define that closed surface, and we're gonna see how that part will look. And now this will have material on the inside, so this will be a solid component. We can add material and other elements, and it will not be considered just a surface. It will also have that inner material added. Now this was easy because it was directly along the axis, so we just raise a plane over here. But if I want to do a projection maybe somewhere over here, let's see how we can do that. The easiest solution is to define a point. For example, we can do that in generative shape design. I can go over here on the point, and we can make this on a surface. I can select the surface where I want to add this. And now we can have this position, for example, over here on the surface. We're also going to have the direction, as we can see over here. There are various approaches over here. We can use the compass definition. And as you can see, this will add a point over there. But for example, if I will go to 50, we're gonna see that there won't be any solution because this is not directly on the surface. Therefore, I will go to a side view of this, and I will add a point over here, so point on surface, and I will add this at 100 millimeters. So we're gonna have the point added over here. As you can see, the point is on the surface. That means that we can now create a plane, and this plane can be tangent to surface. But as we can see, for the plane definition, when we choose tangent to surface, we need to specify the surface. In this case, we have the closed surface, but we also need to specify a point. And we're going to have that plane position over there. There are other approaches on how we can add a plane over here. We can construct a line, add that based on that line, but this is also a working approach in this case. And now I have the possibility to jump over here, and I can create a sketch. For example, I can create a sketch like this. We can see that since this was tangent over here, the circle, if it will be offsetted from the middle, will look like this. So this should be projected. But we can also do a different approach. We can make use of the circle over here, which is not underneath the sketch, is directly over here in generative shape design. And as we can see, for this we need to define, we can do multiple types, but I will choose center and radius. I will select that center. Now for the support, I will select the surface, and we're gonna see how that will be positioned over there. For example, if I will type in 10, I will define the full circle. This will be just the same as if I will move that initial circle over here, because if I'm gonna slightly rotate, we're gonna see that this won't be projected, so this will be created on that tangent plane. So keep that in mind. Therefore, we should do the projection for this as well. And for the projection, we can have that selected, select the support, And again, we're gonna need to specify, in this case, as we can see, the direction that we currently don't have. So let's see, in order to give that direction, I will also create a line. I want this line to be tangent or normal to curve, in this case, normal to surface. And I can specify the surface, I can specify the point, and I can have this reverse, and this line will give us the direction of the projection. Therefore, if I will go now to projection, projected will be the circle, the support will be the surface over here, and we're gonna also have that direction. And we're gonna see that projected circle, which will not be deformed, so this is important. Even with or without the nearest solution, since we have that direction added by the line, which is tangent to the normal over here on that point on the surface, this will be projected over there. And now starting and using the same workflow with extrusion and join that I previously showed, you can easily do that cut directly over there. Okay, so I hope that you find this video useful. I saw that there are no, let's say, in detail video regarding this on YouTube, and this is why I decided to make this. I will also position a similar video over here to the left, and the playlist over here at the top. So the playlist, as we can see over here, currently has around 82 videos, and these are all focused on CATIA. I have different playlists for SolidWorks, for Fusion, and also for Blender. So I highly recommend that you're gonna check this tips and tricks video regarding CATIA V5. Okay, so thanks for watching. See you in the next video.